Now, in this video, we are going to take up one more problem on a projections of laminas. How to analyze this problem in 3 dimension and write the solution on the sketchbook. The problem reads as a hexagonal lamina of sides 30 mm is resting on HP with one of its corners at VP, and its surface is inclined at an angle of 30 degree with VP. The diagonal passing through the corner is in VP is inclined at 45 degrees to HP. Draw the projections. So to do that, so here he takes the initial position, because since it is resting on corners on VP, obviously you have to start the problem from VP. So all the sides should be parallel to VP. Since all the sides are parallel to VP, so you are getting the true shape in the vertical plane. So since it has to be corner is on VP, so you should keep the hexagon in such a manner that the end point, the end of the hexagon will going to be the corner position. So that means you keep the two of the parallel edges should be parallel to VP. So this is how you have to place the initial position. So what is the position of the surface with respect to both HP and VP? The position of the hexagonal lamina is parallel to VP and perpendicular to HP. Since it is perpendicular to HP, you are getting a line in the horizontal plane. As you look from the front view, since it is parallel to VP, you are getting the true shape in the vertical plane. So you got the hexagon here. And this is the hexagon what we are talking about, which are in space. As you look from the front view, the image of the hexagon will going to fall on the vertical plane. As we look from the top view, the image of this hexagonal surface will going to be a line in the horizontal plane, because that the surface is perpendicular to HP. So as we look from the top view, ABCD is near to the observer, so ABCD is visible, and E and F is away from the observer, so it becomes invisible. So now, how to start with the problem in the sketchbook? So first what I need to do is, first you will go to draw the XY line and mark VP and HP. So since we need to start the problem from the vertical plane, so first I need to construct the hexagon. How to do that? So what I need to do is, you take a radius of 30 mm, you draw one horizontal line, and you take any point on that horizontal line and draw a circle of radius 30. Then this circle will going to touch on the horizontal line which you have drawn at 2 points. So with this as center, and we mark that point as A dash, and we mark that point as D dash on that horizontal line which touches there. So then with this as center, that is A dash center, cut an arc on the circumference of the circle here and also on this side. Similarly, with this as center, take the same radius 30, cut an arc on the circumference of the circle at this and also at this point. You mark them, that is B dash, C dash, E dash and F dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to F dash and F dash to A dash with a dark line. Then I need to project each of these points which is from the front view to the XY line. So I will draw a vertical projector from A dash to the XY, similarly from D dash, similarly from B dash, F dash and also from C dash, E dash to the XY line. As you look from the top view, A dash, B dash, C dash, D dash is visible, so A, B, C, D is visible. E dash and F dash is away from the observer, and it is coinciding with C dash and B dash, therefore it should be in bracket. So we mark this as E and F in bracket. Then join between A to D with a dot line. So this is how we will be able to write the initial position of the hexagonal lamina. Now, since it is to be resting on one of its corners on VP, make sure that the hexagon is rotated such that one of the corners on VP, as you look from the top view, the corner will be on XY line, and the surface being inclined at 30 degrees to VP. Once the surface becomes inclined to 30 degrees to VP, the diagonal AD will going to become apparent length here. That is A dash D dash. As you look from the front view, this rotated hexagon will be projected onto the vertical plane, and as you look from the top view, you will going to get the surface still perpendicular to HP. So you can see this is the surface inclined to VP and perpendicular to HP. Therefore, in HP you are getting a line. So you make this rotation by an angle of 30 degrees. So all these images have been, all these points have been transferred here. Similarly, as you look from the front view, so this is A dash, B dash, C dash, D dash, E dash, F dash. So the points which are in space is being projected onto the vertical plane, and the points which are in the horizontal plane will be projected onto the horizontal plane. Then what is the position of the surface with respect to both HP and VP in the second position? Means in the second position the surface is inclined to VP and perpendicular to HP. So this is how you will be able to analyze. As the surface becomes inclined to VP, the diagonal AD, which was parallel initially here, has become inclined. So once it becomes inclined, so you are getting the apparent length here. But whereas AD is still parallel to HP, so you are getting the true length here. Now, then he says how to write this in the orthographic view. So you take any convenient distance from D to the second position top view and you mark that point on the XY line because it is one of its corners on VP. So which is the corner here? Either you can take A dash or you can take D dash, because the corner, you always remember, you have only one point at the end. So here A is the one point which is at the end, or D is the one more point is at the end. So since it is corner to opposite is a corner in the hexagon, so you can rest A is on VP, but here all the sides are on VP, but I want only one corner is on VP. So you consider a corner, then by using the protractor you measure an angle of 30 degree with respect to the XY line in the bottom side, that is by clockwise, then draw an inclined line passing through that 30 degree line. Then you measure the distance from A to D by using the compass and transfer it from A to on this 30 degree line, and you mark that point as D. Similarly, you draw by using the measurement from A to C, which is the same as D to B. You measure the distance from A to C with A center, cut an arc on this. Similarly, with the same radius with DS center, cut on the previously drawn line here. So that you are going to transfer all the points. Then you transfer all these points here. A, B, C, D, E is in bracket and F is in bracket. Once you do that, then you draw a horizontal projector from both A dash and D dash and draw a vertical projector from both A and D. So both these two lines will going to intersect at these 2 points. You mark that point as A dash and D dash. Similarly, draw a horizontal projector from B dash and C dash and draw a horizontal projector from F dash and D dash to the second position front view. Similarly, draw a vertical projector from B and F to the front view. Similarly, from C and E to the front view. And you mark these points as B dash, C dash, D dash, E dash, and F dash and D dash. Then join A dash to B dash to C dash to D dash to E dash, E dash to F dash, and F dash to A dash with the dark line. As we see that when the surface being inclined to HP, what happens to the diagonal AD? The diagonal is also becomes inclined. Once this diagonal becomes inclined to VP, so you are getting the apparent length here. This is how you will be able to write the second position, top front view and top view. Now, then once the diagonal becomes inclined, once the surface becomes inclined, the diagonal will also become inclined, so you are getting the apparent length. The inclination given here, one of the diagonal is inclined to HP at 45 degrees. So the diagonal passing through the corner on which the lamina rests is inclined at 45 degrees to HP. So you are after finding out the beta inclination, you are rotating this in space. which is the one which has been provided with the grain surface. Now, once it is in space, as you look from the front view, all these points will be projected onto the vertical plane. So you got A dash, B dash, C dash, D dash, D dash, E dash, E dash, and F dash here. So similarly, when you look from the top view, all these points images will going to fall on the horizontal plane. So A is already on VP. So B and F is on, now is on B, that is on HP. Then you have C, D, E. You can project from C to the top view. Similarly from D also and from E also. So this is how you will be able to write, you will be able to analyze it in 3 dimension. But only thing is here in this case, since one of the diagonal which was parallel to HP, so then the diagonal becomes, the surface becomes inclined, then the diagonal becomes inclined. So you are getting the apparent length in the second position front view. But when you want to rotate the second position front view into the third position, there it becomes, he has given the true inclination, but here you have got the apparent length. So since you have the apparent length, I need to find the apparent inclination. On that inclination, you create this drawing. So that is what we have done here. The same way, how to write this down. So you take any convenient distance from D to this point. So you consider any point, draw a horizontal line, and you measure an angle of 45 degrees with respect to that point, and then draw an inclined line here. This is the one which we are talking about. So we make that A dash is on that 45 degree line. Whichever way you want, you can do it. Now, once you consider this A dash, then by drawing at an angle of 45 degree, you measure the true length of the diagonal. Where is the true length of the diagonal? The true length of the diagonal is here. Why? Because AD is parallel to VP, so you are getting the true length in VP. So you measure the distance from A dash to D dash from this first position front view. With the same center, cut an arc on that inclined line which is at 45 degrees. Then draw a horizontal projector from that point to this. Then, as we know, in the second position, once the surface becomes inclined, since the diagonal is on that surface, therefore you will get this diagonal length will be apparent length. So by you taking measurement from the compass with A dash's center, take the radius of A dash D dash with A dash's center, cut it on the locus of the front view. Once you do that, you mark that point as D dash, then join A dash to D dash and extending it. So this is the angle alpha what we are talking about. Then you measure the distance from A dash to this point, which is same as from D dash to this point. So you transfer from A dash to this line, which is the alpha inclination line. Similarly, with the same radius with D dash center, cut on the previously drawn arc. Then join between D dash to A dash and extending it. This angle will be alpha. Then you measure the distance from this point to F, which is same as from this point to B dash. Similarly, from this point to E dash will be same as from this point to C dash. So with B dash, so you yes. Now what I need to do, once you get this point, now with A dash's center, take the distance from A dash to this point, which is the same as from D dash to this point. So from A dash, you cut it an arc on that alpha inclination line. Similarly, from D dash also, you cut it on this alpha inclination line. So through this line, by using the protractor, you measure an angle of 90 degrees and mark that point with reference to A dash D dash. At this point and also at this point. So draw perpendicular from both these 2 points and extending it on either side. Then you measure the distance from this point to B dash, which is same as from this point to F dash. Similarly, from this point to E dash is same as from this point to C dash. That means all these 4 segments are equal. So with this as center, cut it on this perpendicular line and also on this side. Similarly with the same point, from this point, you cut it on this line and also on this line. And you mark this point as B dash, C dash and E dash and F dash. Then join A dash to B dash to C dash to D dash to E dash to M dash and F dash to A dash with a dot line. Now I need to write the third position top view. So to do that, draw a horizontal projector from A from the second position top view and also from D, and draw a vertical projector from A dash to XY line because A is on XY line, and similarly draw a vertical projector from D dash and also draw a horizontal projector from D. Both these two lines are going to intersect at this point. You mark that point as D. Similarly, you draw a horizontal projector from B and F to the third position top view and draw a vertical projector from B dash and also from the F dash on the same line. So then you will going to get this point B and F. You mark those 2 points. Similarly, draw a horizontal projector from C and E to the third position top view and draw a vertical projector from C dash and also from E dash. So both these 2 lines will going to intersect at this point and also at this point. You mark those 2 points as C and E. Similarly, draw a horizontal projector from D and draw a vertical projector from D dash, and both these 2 lines will going to intersect at this point. You mark that point as D. Then join A to B, B to C, C to D, D to E, E to F, F to A with a dot line. So this is all. You will be able to analyze this problem in 3D and also solve it manually by the sketchbook. So ultimately, how do I know that my drawing is right? You can see that the diagonal passing through the corner on which the lamina rests is inclined at 45 degrees to HP. So since you have given the true inclination and the length what you have is the apparent length, therefore I cannot transfer this directly. So in such a case, I need to find out the alpha. How to find out the alpha, which we have already explained. And so since it is inclination is the true inclination and the length what you have is apparent, therefore I need to find out the apparent inclination here. And even in the final position, you can see that the corner is resting on VP and the surface is inclined to VP at 30 degrees, and you have a true shape of 30 mm side by using the hexagon. So this is all. And since we have incorporated all the data which was given in the problem, and hence my problem